Hello again, everyone, and thank you for attending today's webinar, How to Integrate Prototyping into the Design Process Using 3D Printing, brought to you by Stratasys. We would like to thank our presenters, Jim Warner, Global Managing Design Director at Kaleidoscope, and Jerry Barbarian from Stratasys for being here today. I'm Leslie Langnaw, Managing Editor at Design World Magazine, and I will be your moderator. Just a couple of housekeeping details before we get started. If you wish to tweet about this webinar at any time, you can use hashtag DWWebinar. This webinar will also be made available online and via email shortly after we have finished with the webinar. And we will have a Q&A session at the end of the presentation. But you can go ahead and submit your questions on the panel that you see at your side, and we will ask them after the presenters are finished. And now I would like to introduce one of our presenters. Well, I'll introduce both of them, but we'll start with Jim. Jim Warner is the Global Managing Design Director of Kaleidoscope, a co-creative and brand realization agency headquartered in Chicago. He leads his team through invention and orchestration of iterative design thinking, rapid ideation, iterative prototyping, innovation, rapid research, strategic brand direction, creative technical design, strategic validation, domestic and global manufacturing, and implementation liaison to provide creative solutions in brand strategy and design, structural packaging, product design, and merchandising. Jim is a creative visionary, industrial designer, and consultative executive who has created some of the world's most iconic and powerful branded products and packages. He is a former professor at the Parsons School of Design and the Pratt Institute of Design, awarded numerous He is a former professor of Parsons School of Design and the Pratt Institute of Design, and he's been awarded numerous international awards and almost 100 patents, and he is the recent recipient of the Massachusetts College of Art and Design Distinguished Alumni, where he earned his BFA in Industrial Design. Jerry works with the Sales Operations Department at Stratasys, Inc. He provides key application guidance and expertise for rapid prototyping professionals across various industries, including automotive, consumer goods and electronics, medical, and others. Prior to Stratasys, Jerry worked for GE Design and Components, where he held the position of aircraft engineer and led projects for GE's gas turbine and engine designs. He's also a mechanical systems design engineer for the construction design industry. He is the recipient of the Pratt & Whitney Design Award and holds a BS in Mechanical Engineering from Boston University. So without further ado, I'm going to hand over the mic to Jim.
All right, thank you everyone for joining, and thank you, Leslie, for a wonderful introduction. To start out, I'd like to frame up who we are a little bit and go through quickly kind of our frame of reference as we get ready to discuss how to integrate prototyping into the design process, and with a highlight on using 3D printing. Kaleidoscope is the world's premier integrated design and realization agency, where we integrate various design competencies with strategy and other components and utilize realization, which is in prototyping and comping. As an overview, we believe in a brand as an ecosystem. I mean, as a large overview, it's understanding that a brand, which ultimately, whether it's a product design or package design, it ultimately becomes and is a brand. And brand is an ecosystem, which is a collection of integrated or interconnected elements that communicate a promise to people. So as we go through our presentation and talk about how we're creating things, we want to keep a high-level profile, understanding, and realization that we are, in fact, developing brands. And our consumer insight-driven approach allows us to strategically position brands within the context of retail. So it's about developing brands as products, as packages, in the context that people interact with them in a venue. Through co-creation, our organization, we combine multidisciplinary team perspectives to solve problems and uncover new opportunities. So it's a multifaceted series of competencies that develop ultimate solutions. We provide integrated services as well under the auspices of iterative design thinking. These integrated services include user research, consumer journey mapping, and other strategic components around understanding how strategy and consumer connects together, design and brand strategy, category analysis, brand design, structural packaging, engineering. Now, before beginning, and this is just an overview of our organization, but before beginning, for any of us to develop an understanding of how we're going to best utilize prototyping in the design process through 3D printing, we need to clarify and completely define what prototype means to you. So everybody that's listening, everybody needs to be able to define what prototype means to them in their organization. Now, as a definition, prototype is an example, a sample, a model. So by rigid definition, that's what a prototype is. Now, in a design language, and whether you're a designer or an engineer or technical or packaging or in marketing or in brand, there are slang terminologies and methods of modeling that are very different. And again, understanding what prototype means is important, and understanding all of the relevant ancillary terminologies is very vital as well. And that can be called breadboard, POC, which is proof of concept, looks like, which means it doesn't work like, but it looks like it would when it's ultimately completed, whether again product or package. It's solid or hollow, it's rough or finished, and these are dichotomous, obviously, or they're 3D visuals. From the standpoint of what the prototype means, from a hard definition to slang and terminology, how does it function? What is its meaning as far as what does it provide for the development process? It can be from an aesthetical standpoint, functional, or a technical and manufacturing evaluative tool. Now, the next thing you need to do is answer the three very important questions as we're developing an understanding of what prototype means. What you're ultimately going to need to understand is what does it mean in the context of your organization and the work you do, and also three important questions to really evaluate how you're going to be developing and integrating prototyping into your process. Number one, very important, is what business are you in? Now, it's very easy to, just utilize models and develop objects without really understanding completely and reminding yourself the business that you're in. Are you in the business of developing ideas? Are you in the business of putting things to market quickly? Is it around economics? Is it around competitive environments or categories that you need to be swift to move in and out of? Is it a trend-related business where you need to constantly be on the forefront of emerging or mega trends? So carefully understanding and answering what business you're in is critical to develop what's the right way to integrate prototyping into your process. And then, what is your creative development or manufacturing process? What is the process that you follow and develop concepts for to ultimately deliver to marketplace? And then a very careful and substantial analysis of how do you make things within that process. So again, the business you're in, the creative process that you follow, and how do you make things? What types of equipment, what types of machine, what type of people, etc., are making the things that you develop. Now, based upon your analysis and based upon the work of both defining what prototype means as well as the three important questions, the business you're in, the process, and how do you make things, you then need to redefine yourself. And that's not a very easy thing. And unveiling yourself, to redefine yourself, you have to unveil ultimately a new process. Now, developing the process and unveiling it and rolling it out is a major component in being able to integrate prototyping into that process. Unveil your new organizational structure and staffing requirements. A new process doesn't necessarily mean that you utilize all of the same people that have been involved before. You're then going to need to get to another level of a shifted organizational structure. And then thirdly is to procure new and advanced equipment to provide for the organizational structure that's been revamped to provide for your new process. Okay, the crux of the matter is then, which 3D printer should I purchase? Which one is the best? Let's get kind of specific. Well, the issue then is there are so many out there. What do I choose from? There are large ones, small, there are additive, subtractive, there are complicated ones, there are tabletop ones, there are a myriad of various things out there. Now, before you get overwhelmed, wait. And let's back up for a moment. And whoever said that you need to only get one 3D printer? Many times, you know, people kind of jump to the conclusion that it's one new thing, one new object is what you need. Now, a very simple comparison would be, as a car mechanic, does he or she only have one tool to fix cars? And the answer is, of course, no. So to make things in today's business world, you need a vast array of different methods. And you have to do things faster, bigger, and better than you ever have before. That's just the requirements of today's economics and structure of companies. And you have to have a culture and a leadership and a vision that supports your change. And above and beyond all that, it's the understanding that process is king. So as you're developing a complete understanding of who you are, what you do, and analyze yourself in a new process, let's look at a process that we utilize and think is very, very important and supportive of utilizing prototyping into the process, particularly with 3D printers. The first thing is iterative design thinking. It's the way you think. It's the way you process information and solve problems to define solutions. The next part of the process is rapid ideation. So it's the mental gymnastics that's involved in the thinking, and then the ideation itself that needs to be very quick in today's market, whether you're consultative or in-house corporate, is ideation needs to go very, very quickly. And that can be, instead of weeks and months, it could be, you know, days and weeks. Iterative prototyping is a new component in design process that we feel is, you know, very, very critical. So no longer is it, you know, sending out for you know, elaborate models and prototypes, but iterative prototyping at the moment on the cusp of rapid ideation is to prototype iteratively. And this is where in a moment we'll go through some things that we use and we would strongly recommend thinking about as far as how 3D printers integrate in and support iterative prototyping. And iterative prototyping provides for more information at a faster pace to make better decisions quicker to get to market with a better design. And then number 4 is rapid feedback, the ability to get objects, products, packages, etc. in front of consumers or stakeholders for their immediate feedback. And this can be iterative, this can be certainly qualitative, this can even be quantitative. But the ability to get things out into the arena for people to feedback. Number 5 is technical refinement. This is the beginning of really getting very, very specific in with engineering and technical design and development as it relates to operations and distribution and some other components that might be relevant. Number 6 is consumer validation, the ability to then utilize equipments and processes and people to then get consumers to validate, which is the final stages of design process, which then finalizes the design and freezes it. And then number 7 is production liaison, so we're going into the production level. And then ultimately a rollout, which is launching it into the marketplace and then evaluating not only the results, but evaluating the process that you went through. What I'd like to do now is a little deeper dive into the overall development process, integrating model making. Now, we're talking about 3D printing specifically here. What I'd like to also bring to everyone's attention is that by itself, 3D printing isn't the only thing you should be doing. It needs to incorporate other types of developing objects, particularly in the model making arena. The very first, the iterative design thinking process, the deeper dive into that, it's under the mantra of what we call fail fast forward, which is iterative. It's instead of doing a elongated elongated portion of a program that could be 7 or 8 or 10 or 12 weeks, we break it up into smaller iterative components. And what we use for creating objects, again, product or package, is things from cardboard and foam core and clay, and we carve things in a very iterative fashion. And from a 3D modeling standpoint, in-house for us, we have the MakerBots, which are desktop, what we would call kind of crude or breadboard rapid prototyping equipment, which enables us to get in front of people, in front of design teams, client, stakeholders, lots of information, quick, a lot rougher, but the ability to nonetheless evaluate things at a very high level. Still, though, very crude and very fast. The second part is around development, and this includes rapid ideation, iterative prototyping 2 and 3. And you can see what we've listed out here, the kinds of things that we would use and suggest thinking about using in the process and integrating prototyping into the process of design and development. For rapid ideation, we kind of go to a higher level. Again, we have gone through ideation. Now we're going into development, which is starting to fine-tune, refine, and even shortlist and select. CNC, we construct things. We do scanning and cutting. REN is a material of choice. We use, again, MakerBot, and then Object and different types that we'll use for rapid ideation. And this becomes a very important component at this stage of the game, not necessarily relevant to the very first parts of the stage where we need to get a lot more things out quicker, but Object in phases 2 and 3 plays a very critical role in becoming the offshoot of preliminary 3D database development. And then in phase 3, we go to, again, a higher level. Again, we're iterative prototyping. We're making prototypes for feedback, for research, and we're utilizing 4-axis mill, CNC, additional prototyping and modeling processes of vacuum form, REN. Again, Object, SLA comes into play here. And then some RTV castings, moldings, and other decorative things we can do from a paint application or graphic application. And then 4 is the feedback. Again, putting it in front of consumers, in front of stakeholders, both customer side, client side, and our own team. And again, it's the same array of things in 3 with the additional component of soft tooling and constructing objects where we might be doing more research type endeavors that could be in-house, in-home, central location testing, things of that sort. And the last implement component and how and what we use in those processes would be, technical refinement through to production liaison is object, and object to the level of not of smaller pieces and parts, but actually maybe even utilizing object, the newer one that Stratasys has, where it replicates soft tooling for injection mold, and even in some trial things we're doing with blow mold. SLA we're still using to understand the part integrity, as well as into a production liaison. We're actually utilizing, creating pilot tools. Now, if we look at how that would be related to the objects in this image here, we follow through the process of developing a structural package that we're doing for Fair Oaks Farm through their Fairlife brand for milk containment. And you can see in phase 1, it's around utilizing rough hand-cut foam. Then when it goes to rapid ideation in number 2, phase part 2, we're utilizing Ren material, we're utilizing 3D database and combination of CNC and actually 4-axis mill. And then in 3, iterative prototyping, we're then starting to develop hollow objects. This happens to be a thermoform mirroring the hollow component so that we can pour liquid in it and then have people interact with it. And then 4, feedback. What we're taking is the object from 3, enhancing that technically, and then adding the brand and graphic communication. In this case, it's a full body shrink band. And then in technical refinement 5 through 8, we're developing actual soft tool blow mold. And then in the final one, it's actually high volume blow molded containments. So what have we learned about process and about model making, which incorporates 3D printers as well as other methods for model making? One of the important things is to learn to fail often. Now, this might seem counterintuitive because, the thought going in might be 3D printing and rapid prototyping and efficient processes make surer decisions and quicker, quicker to market. And usually we think of that as we succeed immediately. Well, the reality of it is you learn to fail often. If you fail often and faster, you get better decisions and better designs quicker. It immediately seems counterintuitive, but it is the crux of the most successful design and marketing organizations today. The next is to think different. And thinking different means, quite simply, don't keep thinking the way you used to and don't think about it the way it was done before. But what we've learned is to really be able to think differently day in and day out as you're developing processes, as you're reevaluating yourselves, and as you're evaluating the design programs that you're undertaking. And thirdly is to be upfront and honest. There's no glory in trying to hide either disappointments or failures or problems. These kinds of utilization of advanced processes and model making and utilizing 3D printers to get things done quicker and faster and better, You need to be completely transparent and upfront and honest about how it's all working. And don't settle for less. Don't settle for things that, well, we got it faster, but it's a poor rendition. We got it, cheaper, but it's not really the quality we want. Don't settle for that. Technology is supposed to be, a component of thinking and design and process, and you should never settle for anything less than what it is you desire. And lead your technology, number 5, as opposed to allowing technology to lead you. You need to define your process, the people doing it, the organization that's supporting that, and be able to then utilize and harness technology for the benefit of what it is you do day in and day out. And lastly is don't copy others. You see an organization do it a certain way, even the way we're showing how we think it could be done. Replicating it just means you're duplicating someone's efforts, but more importantly, someone else's rationale and reasons for doing so, which might not be exactly to the points that you need to define for your business and the business you're in and the work you do and the things you need to do to be competitive. So a challenge to all attendees, we very strongly recommend to integrate competencies, integrate thinking, integrate the things that you do normally in silos or in separation, but doing them together will get us to a stronger point. Secondly is to innovate. Now, innovate can be something simple, something grand. Innovate doesn't have to be done by the person in your organization that has innovation as part of their title. Innovating can be done by everyone and should become a component of the overall work that you do. It needs to be part of all the work that's done. And lastly, model. Continuously develop and make things and build things and create things that are part of developing the design work. Modeling is an integral part of making a product or a package and should not be saved until the very end. And with that, thank you.
Thank you, Jim. And we're going to have Jerry give his presentation in just a second. Just a quick reminder to everyone, go ahead and put in any of your questions that you would like to have either Jim or Jerry answer at the end of the presentations. And now I'd like to introduce you to Jerry. Jerry, are you there?
Yes, hi, how are you?
Hi, okay.
Okay, well, I hope everyone's doing well this afternoon. My name is Jerry Barbarian. I work for Stratasys. I am out of our Billerica office, which is just north of Boston. I have been with the company for just about 5 years now, and today I am the Senior Applications and Pre-Sales Engineer here out of this office. I come from the Objet side of the business. So I'm sure most of you have heard that Objet and Stratasys merged right at the beginning of the year. And I think this was a great merger. I think that this merger was able to fuse two leading technical innovators at the forefront of 3D printing and make an excellently strong company that has a lot of very innovative and interesting things to offer. So let's go ahead and take a look at the company. Get this slide to move forward. There we go. So Stratasys. We have a dual headquarters right now. What we have is a headquarters in Rehovot, Israel, which came from the Objet side, and a headquarters in Eden Prairie, Minnesota, which came from the original Stratasys side. Together, the two companies now have over 1,100 employees, and we are continuing to grow and continuing to hire at quite an astounding rate. It's pretty amazing, especially sitting from where I see it, as to how we're growing. In 2012, we have a combined revenue of almost $360 million, as well as we reached 500 granted or pending patents. We're currently at about 20 technology and leadership awards, and our install base is up to over almost 30,000 right now. We're just over 29,000 3D printers installed, and that's worldwide. So let's take a look at our customers. Now, as you can imagine, and as Jim mentioned, any company that you can imagine that does 3D printing could be one of our possible customers. And what you see is customers on the right and just a handful of industries we pulled on the left. We just picked a few out of our more than 8,000 customers to show you on the right. And you can imagine that our customers are a very, very wide range of customers. We have everything from multinational companies that you can see on there, all the way down to mom and pop design shops. Okay, from the industries, you can see a range of industries. Some of the top industries we have are the automotive industry, consumer products, the education, medical. But you can imagine that anyone in any industry that is going to be designing anything is going to have the need for prototyping. So we take a look at Stratasys and Stratasys's product offerings. And as you can imagine, the design process that we would normally go through would be 3 phases. In that design process, we would touch on the concept design, the prototype, and the production. And Jim actually went through those 3 stages much more detailed than I'll touch on. But as you can imagine, those being the 3 basic stages. And what Stratasys has done is that we've offered machines in 3 different families to be geared towards those different sections or stages of design. So we have machines such as our Mojo, which is our desktop FDM printer that is used and geared towards the concept design. We also have machines that are geared towards the prototyping section and the production section. On this slide, what I wanted to show was just a range of the different materials we have to offer. On the next slide, I'll cut the technologies in half and talk a little bit about the 2 technologies. But what we can see here is a range of materials. And the materials range from, on our FDM side, we have thermoplastics, which you'll see on the left. This ranges from ABS all the way through to our high-grade engineering materials, very chemically resistant, very high heat resistance, all the way up to our Ultim materials, which is an aircraft-grade engineering material. And they're all plastics. And then on the right side, what you'll see is our photopolymer side, and this being our objet or polyjet technology. And with that technology, we have the ability to print rigid plastics, but also flexible rubbers, ranging all the way through your standard plastic ABS similar materials, all the way to biocompatible materials for hearing aids, materials for dental. And then also we have a technology that we call our Connex technology, which gives us the ability to combine 2 materials in a single machine, in a single print job, and actually create new materials we call digital materials. So what that is if we were to take one of our rigids and take one of our flexibles and combine that together with our Connex technology, we can create new materials. So the last thing I wanted to show you guys was basically how in the new Stratasys company we have 2 separate technologies, but both that complement each other very nicely. Here you see our objet machines, which use a polyjet technology. The polyjet technology uses a liquid resin. It's a photopolymer, so it's cured with UV light. And we lay that liquid resin down in a tray, we cure it with a UV light. And that's really the basics behind the objet technology. We have lots of different types of resin, as I mentioned, from rigids to flexibles, from opaques to clears, but it's the same process for each resin. Right? And with that technology, we see that the technology lends itself towards very fine details. We have an incredibly high material versatility of over 120 materials, including our regular base materials, but also our digital materials, the combinations that you can get on the Connex technology. And what that really offers us is a product realism, something that only the PolyJet technology can really bring to light, being able to take those rigids and those flexibles and combine them, create new materials, or create several materials within one assembly or one build. Moving over to our FDM side, what we're looking at here is a fused deposition modeling technology where we're using a plastic filament or strand, and we're bringing that through a liquefier and an extruder. And what we're doing is actually tracing out a layer. And then once that layer is complete, tracing a layer on top of that until we build a full part. And what that technology brings forward is really a range of materials, engineering materials that is a step above what we're used to. As I mentioned, the Ultim material, that's a material that is really a step above our ABS, where you have a high chemical resistance. You have a flammability rating to it, a very, very high strength to it. And what this really offers us, as I mentioned, was complementary technologies, a technology where we see that throughout fit, form, and function, we have the ability to have precision and also a precision and material properties of the FDM side. So as Jim mentioned, and I think it was a great point that he brought up, people often think or are led to believe that they need to pick, quote unquote, the right 3D printer. And something that I myself have always believed, I've always taught, is that no one printer, one technology can do everything for you. All right? And I always said that if you can find a printer that will do approximately 80% of your prototyping, that's excellent. And then that other 20%, you can go to a service bureau for it. And what I really like with the pairing of these two technologies is that you now have two technologies, the PolyJet and the FDM technology, that complement each other, and together those two technologies can tackle almost every prototyping need that you will have as a company. Thank you very much, and I'll turn it back over to Leslie.
Thank you very much, Jerry. And thank you, Jim, too, for both of excellent presentations. We're now going to go into the question and answer portion, and we already have several questions that have come in. So one of the first ones is, with 3D printing, are there any warpage issues? And if so, is there a rule of thumb on what to expect? Either of you want to take that one?
Sure, I'd be happy to take that one. Yeah, this is Jerry. Warpage can be an issue depending on how thin you print your walls and depending on which material you choose. And the best guideline to avoid any material warping is to make sure that you choose the correct material for the correct application. You know, as I mentioned, we have now a range of, from the object side, over 123 materials. For the FDM side, a whole nother 20 plus materials. And there's a lot of materials we can choose from. We just want to make sure that for a given application, we look at pressure, we look at temperature, and we choose the right material for that application.
Okay, and this one I think might be directed more for Jim. You use a number of construction methods to build prototypes. Do you find that having 3D printing capabilities reduces the effectiveness or utilization of these other methods, such as foam core, cardboard, and so on?
No, no, not at all. I think they're all complementary. As Jerry's gone over, the things that a 3D printer can provide are replications of real, actual produced parts, and do a tremendous job of that. And all of the choice of materials, it's just you can create anything that replicates something real. Utilizing cardboards and foam core and things of that sort will get you kind of roughed out designs and solutions. So it's not that one takes over the other or is better than the other or worse than the other. I think you need to be able to utilize a myriad of different modeling techniques to design, develop, and validate and implement work into the marketplace. So I don't really think it's a matter of one bastardizing the other or degrading its capability. I think they're all very, very complementary and need to be done accordingly.
Okay. Now here's a question that says, if the part is designed with 20% GF ABS, then how strong will the 3D prototype part be? Anybody?
I'll be happy to take that one. Yep, I think that's an excellent question, but unfortunately, as we see in a lot of cases, those parts are going to be what we like to call geometry dependent. So without being able to see the part that you're talking about, it would be very hard for me to give an answer to that. As a side point, one of the interesting things that we see that a lot of our customers are doing is you could go to our website and we have material specification sheets for every one of our materials. And one of the things that our customers do is they take that material specification sheet and they take the different specs on there and they line those up with the specs of their final ABS material. And what they do is just create a relation between those and say you're printing with an FDM machine that's printing our ABS Plus. And you know that is 80 to 85% as strong as the final injection molded ABS you'll be using. We'll go ahead and run all your testing on that and then put in that 85% factor. And that gives you a good answer in your stress tests. I hope that answer helps.
Okay. A question that's come in is, where can someone send a model to get a quote for a 3D prototype?
If you are interested in, there's two different sides to that. If you're interested in just having a prototype done, you could go to Redeye. Redeye is a very large service bureau that is actually owned by Stratasys. And they have all technologies that they can print there. And I believe that they also have a remote quoting tool on their website. So you can submit an STL and then give you a quote of exactly how much it'll cost and how fast they can get it back to you. If you're interested in getting a quote on a machine, you can go to our website, and on that website you can search for a dealer in your location who can then help you take you through for your applications what machines and what materials would be ideal.
Jerry, can you give a quick either web address or something for a contact for Redeye?
I believe it's redeye.com.
Okay. Another question that's come in is, how close of tolerance can you hold in this process and the surface finish for sealing area? I think they're referring to 3D printing.
Okay, great question. Yes, so that would be depending on what machine you go with. The two different technologies can hold tolerances depending on the size of the parts, all the way down to plus or minus 1 to 2 thousandths on smaller parts, and plus or minus 3 to 4 thousandths when you're getting above smaller parts. So those are quite accurate machines. Just depending on which technology you decide to go with and the different geometries of your parts.
Okay. Jim, have you worked with metallic prototypes yet?
Metallic?
Yeah. Or with any metal processes?
Most of that is is in the milling areas and such like that. So I wouldn't really call it. It's more around model making than prototyping and sintering and things like that. Not as much. It's more in the polymer areas.
Okay. This question came in about metallic prototypes and what are the material choices and the processes.
I can answer some of that. Metallic prototypes range in different materials. Normally, or I would say most common would be the SLS, which is a laser sintering process. And those materials can range from steels to aluminums to Inconels. There's quite a range. The materials themselves, the processes, and the machines are quite a bit more expensive than the processes we're talking about today.
Okay. And Jerry, this one is to you. Could you discuss the differences between the low-cost printers and Stratasys printers?
Sure, I would be more than happy to. The low-cost printers like the MakerBot and the other printers using the FDM technology, essentially the differences you're looking at are going to be, number one, software-wise, and then number two is going to be the size of the filament as well as the accuracy and the quality of the model. As you can imagine, that the smaller machines that are more around the $2,000 to $3,000 range today are using the FDM technology that Stratasys was using about 15 years ago, and that's exactly how the technology curve is going for, say, those two competitors. One of the things that the Stratasys machines are using that the lower cost machines are not using is a heated build envelope. And that heated build envelope will bring you a much more reliable print as well as a much more accurate model.
Okay. Jim, how about you? I noticed that you were using the MakerBots in the very early stages of the design process. How have you found that to be?
It's been very helpful. I mean, we use them almost like a desktop printer, if you would, and we use them to rough out general concepts, whether they're product or packaged components. And what we are able to do is sort of fast and quick and down and dirty. We're not looking to utilize the models for high-level evaluation or part fit and assembly and things of that sort. It's really to kind of get the object out and to look at it off the paper and out of the computer. So it's been very effective, and it helps really to quicken the process of development along so that we can then incorporate what we utilize as objet, and certainly looking at upgrading into certain Stratus equipment that we've been talking about as well. And then we can integrate it into the higher levels as we move down in the process of design and development. But it's actually been, in a sense, almost as revolutionary as making, fiery and desktop plots and printing. It's quickened the process immensely.
Okay. Now this question came in, where would you go to get a list of materials that can be printed with a 3D printer?
This is Jerry. I'll be happy to take that one. You could go to stratasys.com, and we have a list of our materials there that you can utilize. That would be the best list for this type of technology. We have the PolyJet technology as well as the FDM technology, the list of materials, and the material spec sheets.
Okay. Now, is there a proven method for orienting a part for printing?
Absolutely. It's always going to be geometry dependent. On the objet machines inside of the software, we have a button that does automatic orientation for you, and that will do the software's best job of orientating it, but orientation will always come down to the geometry that you're looking to print. And whether it is a service bureau or whether you have purchased a machine, once you get your hands on that software and the machine, you'll be educated by our applications engineers and service techs as to what is the best rule of thumb in certain situations.
Okay. How much does the tabletop FDM machine cost? I think they're referring to the Mojo, but that's
Right.
not the DM
Our
machine.
lowest cost machine is $10,000.
Okay.
And that
Oh,
would be the Mojo.
and is there, this is an interesting question, are there any options for optical quality printing, such as for LED optics?
From the PolyJet, the object machine side, yes, we have a material called Vero Clear, which is a clear material. And we do have some customers who have done some different optic applications as well as light pipes and some LED lenses.
Okay. And this question is for Jim. With the advent of direct design to print prototyping, do you see the development of multiple prototype variants in parallel versus serial development offering any advantage? And what are the implications?
Can you repeat that question?
Yeah. So he's talking about the advent of direct design to print prototyping. Do you see the development of multiple prototype variants in parallel versus serial development offering any advantage? And what are the implications? So I'm guessing he's meaning if you do like several iterations, print those out at one time versus doing one and then making changes and so on.
Yeah, I mean, again, it depends on the equipment you have and the processes that you're using. But yeah, we'll tend to not do it so, make a model, evaluate it, make it again, make it. We can, the equipments we have a big enough base size and area that we develop a multitude of variants at the same time and evaluate them against each other and then sort of move forward. There's lots of ways to kind of cheat it to a certain extent in the process. If you're developing a full object, a lot of times you can make half an object. If you're studying a certain part of it, there's not a necessity to prototype and model other components within it. So there's ways to kind of get more quicker to evaluate versus the sort of usual way of making one object in final, evaluated, and such. So it's helpful for that, very much so.
And Leslie, if I just might mention as well, I think that the person who asked that question really nailed on one of the top value propositions for a 3D printer in general, is the ability to design something on the computer in CAD and design 3 or 4 different versions of it and print those all out at once and then run through trial and error and see, be more creative with what you do instead of one design, print and look at it, and then another design, print and look at it. You can print several at once. And depending on, as Jim mentioned, depending on the size of the machine you have, you might be able to do all your designs at once in the same tray overnight.
Okay.
That's a great point. A great point, because even in the design process itself, I mean, you don't do one design, one drawing, one idea, look at it, evaluate it, and then make another one based on that evaluation and so on and so forth. You do a multitude. And the experience that you can have, the engagement with making multiple variations is critical. You can be looking at it from a technical standpoint, a consumer standpoint, a brand standpoint, etc. So the more things you have, the better decisions you can make quicker.
Okay, and this is a follow-up question to the question about the materials for LED optics. The question is, what would the cost of one of those printers be that can print that type of print lenses?
Sure, that would be, you'd be starting at our desktop series, the Object desktop series, and those printers would be around the $50,000 range.
Okay, I'm not sure who this question is suited for, but do you have any special programs for academic institutions? And if so, who's the contact person? Jerry, that might be for you.
Sure. We certainly do have special educational machines and discounts. And Like I mentioned before, if you go to our website, you can put in your zip code or your city and state, and that will locate a dealer for you.
Okay, and this question is addressing maintenance. Is there a 3D printer that is best for occasional use without significant maintenance? Or maybe we could open it up to a broader question of maintenance for these systems.
Yeah, I think that's an excellent question. For those who are just occasional users and are not going to be plugging away on a day-to-day basis, um, I think that depending on your need, usually that user would be a user of our desktop system, and I think the desktop systems are usually a good solution for those occasional users. All of our systems, from the lowest cost desktop to the most expensive production system, have the ability to have maintenance contracts that will cover everything and all maintenance.
All righty.
And if I might interject for one moment, I did make one quick mistake earlier. For the Red Eye Service Bureau, it is redeyondemand.com.
Okay. Do you want to give more prices, Jerry?
I'd be happy to give people round prices, but of course, it's going to depend on what packages you get, what printers you get, and contacting one of our dealers, you would be able to get a much more locked-in area of what you were looking to spend and what machine would be for your application, because it really is solution dependent, not machine dependent.
Yeah, one person was inquiring about what the cost of the Object 260 Connex is.
Right, you're going to be looking at under 200,000.
Okay. And again, the website for Red Eye On Demand is www.redeyondemand, that's one word, .com.
Correct.
Okay, so that's about all the time we have for questions here, but if you have a more specific question or something that is more pertinent to either Jim or Jerry thank you. On this slide, you can see their email addresses as well as their phone numbers. They are both available to answer any of your questions that you want to address one-on-one with them. And just a reminder, a copy of this webinar will be emailed to everyone who has registered, and it will be available on the designworldonline.com website in a little while. So you can also continue the discussion on this on our engineeringexchange.com, which is kind of like a Facebook for engineers. And I'd like to thank Jim and Jerry again for an excellent and informative webinar. Thank you, everybody, and have a great day.